Hello students, welcome. Previously, lesson 23 from 3 topic 2, we were dealing with the third aim of direct titration, that was determining the mass of the analyte in a given volume of a solution. So today, lesson 24, we are going to do aim number 4 or aim number D, that's determining the molar mass of the analyte. Examples. Number 1, we are told a student weighed 1.5 grams of monobasic acid and dissolved it in 250 centimeter cube of solution. Full stop. 20 centimeter cube of this solution required 25 centimeter cube of 0.1 molar sodium hydroxide for complete neutralization. So we are asked to calculate the relative molecular mass of the acid. So to see from the question, we are having sodium hydroxide to be our standard solution because we have its concentration here. So the first step, we are supposed to start with the number of moles of the standard solution, that is sodium hydroxide. So remember, we were having the formula for calculating number of moles as moles is equal to molarity times volume used over 1000. So in our case, our molarity is 0.1. So we're going to write the formula: moles of sodium hydroxide will be equal to molarity, which is 0.1, multiplied by volume, which is 25, divided by 1000. So here we are going to get 0.0025 moles of sodium hydroxide. Moles of sodium hydroxide solution. That's the first step. We have gotten the number of moles of the standard solution. Next, we are supposed to get the number of moles of the analyte by using the reaction between the monobasic acid, which is the analyte, and also sodium hydroxide. Okay, you have to know, learners, an example of monobasic acid include hydrochloric acid, or you can talk about dilute nitric 5 acid. Those are monobasic acid. So if we take, for example, sodium hydroxide, which is our standard solution, reacting with hydrochloric acid, the reaction here, we are going to get sodium chloride and also water. And as you can see, this reaction is self-balanced. Even if you take sodium hydroxide and you react with dilute nitric 5 acid, we are going to get sodium nitrate and also water, and the reaction will be self-balanced also. So that one will tell us the mole ratio between sodium hydroxide and also monobasic acid is 1:1. Okay, so we are going to say sodium hydroxide ratio monobasic acid. Sodium hydroxide ratio monobasic acid. It will be 1:1. So remember, we have gotten the number of moles of sodium hydroxide as 0.0025. So that means if we have 0.0025, we can get the number of moles of the monobasic acid. So there, we are going to say 0.0025 times 1 divided by 1. Here we are going to get 0.0025 moles of the monobasic acid. So we have gotten the number of moles of the analyte. So learners, to go back to the information, check here, we are given 20 centimeter cube of this solution required 25 centimeter cube of 0.1 molar, which it is number of moles we have gotten as 0.0025 moles. So that means this number of moles that we have gotten on the monobasic acid contains 20 centimeter cube of solution as it is volume. So we are going to say, what about 250 centimeter cube of the monobasic acid? So we will say 20 centimeter cube of the monobasic acid has or contains number of moles of 0.0025 moles. So we ask ourselves, what about 250 centimeter cube of monobasic acid? What number of moles will it contain? So there we are going to say 250 multiplied by 0.0025 divided by 20. So here we are going to get 0.03125 moles. So this number of moles of the monobasic acid contains 250 centimeter cube of monobasic acid solution. So therefore, we can get now the relative molecular mass, because remember, we were having a formula as if you want to get mass will be equal to moles times RFM. So if in case we want to get RFM, we have to divide here by moles, then we have to divide here by moles. So that means if we need to look for RFM, the formula for obtaining RFM will be mass over moles. That will be the formula for calculating RFM. So we are going to say RFM will be equal to mass over number of moles, or moles. So this will be equal to, the mass is given 1.5 divided by the moles, which is 0.03125. So here we are going to get our molar mass as 48. So remember, molar mass has no unit, but in case you want to put a unit, you are supposed to put a gram per mole, because to define molar mass, we said it is a mass in grams of 1 mole of a substance. So if you want to put this one unit, you can put gram per mole, or you can leave it like that. That's our answer in the first question. So next, we are going to go to question number 2. So in question number 2, we are told 20 centimeter cube of 2 molar sulfuric acid reacted completely with 3.2 grams of W hydroxide, full stop. We are told calculate the relative atomic mass of W in the formula W hydroxide. We are given the relative atomic mass of oxygen to be 16 and the relative atomic mass of hydrogen to be 1. Okay, still we can use the same formula. We have to get, first of all, the number of moles of the standard solution, which is in our case sulfuric acid, because we have the molarity here and the volume there. So we are going to say moles of sulfuric acid. Moles of sulfuric acid will be equal to molarity, which is 2 mole, multiplied by volume, which is 20, divided by 1000, which was in the formula. So here we are going to get number of moles as 0.04 moles of sulfuric acid. So next, we have to look now the reaction between the W hydroxide and also sulfuric acid. So learners, what you can do is that you can take this W hydroxide to see it has a valence of 1. So you can represent or replace that with sodium hydroxide. So what will happen when sodium hydroxide is reacted with sulfuric acid? How will the question look like? We are going to get sodium sulfate, which is written N2SO4 plus water. So to balance this equation, we have to put 2 here and we have to put 2 on this other side. So the reaction is balanced. So to see the mole ratio between sodium hydroxide and sulfuric acid, it is 2:1. So such like that, the mole ratio between W hydroxide and sulfuric acid will be 2:1. So we can see this by just writing the reaction between W hydroxide and sulfuric acid. So we are going to have W hydroxide, which is solid, reacting with dilute sulfuric acid, which is solution. We are going to get W sulfate, which is solution, plus water, which is liquid. To balance the equation, we have to put 2 there, we have to put 2 here. So let us see the mole ratio between W hydroxide ratio sulfuric acid. So it will be 2:1. Remember, we know the number of moles of sulfuric acid, which is 0.04 moles. So what about the number of moles of W hydroxide? We can cross multiply. There we are going to get 2 times 0.04 divided by 1. So here we are going to get 0.08 moles of W hydroxide. So now we know the number of moles of W hydroxide. Okay, if we know the number of moles of W hydroxide, we can get the mass, the molar mass of W hydroxide, the RFM in other words. Okay, we said RFM can be gotten by the formula mass of W hydroxide divided by moles of W hydroxide. This will be equal to the mass of W hydroxide given here was 3.2. So 3.2 divided by the moles of W hydroxide, which we have gotten as 0.08, will give us 40. This will be 40. So that is the RFM of W hydroxide. So we can get the RAM of W hydroxide, the RM of W in W hydroxide, by just saying the formula mass W hydroxide will be equal to 40. So we don't know W, we said W plus, we know the RM of oxygen, it is 16, it's given in the bracket, 16 plus the RM of hydrogen is 1, will be equal to 40. So we said W plus 16 plus 1, that's 17, will be equal to 40. So if we want to get W, it will be equal to 40, then we take the 17 to the other side, it will become minus. So W will be equal to 23. So that's how we're going to get the RM of W in the formula W hydroxide. So if you're asked the identity of element W, it will be sodium, because the RM of sodium is 23. That's the end of our video.